All right, we're here for Math 321. We've recently finished chapter 9. Let's take a look at some of the questions that we attempt to have on the homework for chapter 9. I have 9.3 open. This is on confidence intervals. Let's just take a look at what we got. Maybe I'll have StatCrunch open in another window. Back to assignments. StatCrunch not going to load. What's going on? StatCrunch is not loading. There we go. This is number 1. It says a simple random sample of n equals 350 individuals who are currently employed is asked if they work at home once per week. Of the 350 individuals, employed individuals surveyed, 35 responded that they work at home at least once per week. Construct a 99% confidence interval for the population proportion of employed individuals who work at home at least once per week. And first thing they're doing is a lower bound and return to around to 3 decimal places. So I'm reading through this problem. It's got 350 individuals. That's my n. Now, everything we've done, proportion and mean and everything has had n. So that's not a giveaway. But then they're telling me how many people responded. And this feels like a categorical response, like a qualitative response. Those who said, yes, I work from home, and those that didn't. So this is sounding like a proportion thing to me. So we'll come over here and we can do stats, proportion stats, one sample with summary. We had 350 observations. 35 of them we're going to call a success. They work from home. And it says it wants a confidence interval. And if you do the homework and you're doing a confidence interval and you get it close, but you're off, you probably didn't change the confidence interval thing right here. This says 0.95. I'm going to do 0.95. I'm going to show you what it gives us. It's giving me to 3 decimal places 0.068. And rounding would give me 0.069. If I go through and change the confidence interval to 99%, now it says 0.0586, which isn't that close, is it? But a lot of people will look at that and say that's pretty close and wonder why you're off. Check your confidence interval and make sure you've got the right percent listed. This said 99%, so we got to use 99%. This will tell you right here what you chose. Yeah. Yeah, I'd rather you absorb it and try to see how StatCrunch works rather than trying to mad dash or write down notes. And the upper bound, I have 0.141, and I don't need to round on that one. That's it. That was easy. Now, the next one says a simple random sample of size n equals 40 is drawn from a population. The sample mean is found to be X bar equals 120.1, and the sample standard deviation is found to be S equals 13.3. Construct a 99% confidence interval for the population mean. They even tell us what it's for. There's like, it's not hidden. Did the last one tell us what it was for? Yeah, it did. It said population proportion. So it tells you what category it is. So the difference between these two, we use t-stats for the mean. For proportions, we use proportions. Other than that, it looks kind of similar. One sample with summary. I need to have a 99%, so I'm going to come down here, set this to 99%. And now I got to enter in all this information. N equals 40. Standard deviation is 13.3. Sample mean goes at top, not 40. Look at that. Pay attention to what order it's asking for stuff. We click compute and it says round to 2 decimal places. 114.40 looks like it's going to round up to 41. And the 125 is not going to round. That's it. These are many of the kind of things we're doing in here. Says in a random sample of 31 criminals convicted of a certain crime, it was determined that the mean length of sentencing was 55 months with a standard deviation of 13 months. Construct and interpret a 95% confidence interval for the mean length of sentencing for this crime. All right, so it's mean. So we're doing stats and t-stats. One sample, we don't have data, so we're going to use summary again. The sample mean, there's no decimals on this. 55, 13, and 31. Confidence interval, we leave it at 95%. They want us to round to 1 decimal. So I got this lower limit and upper limit. I got to come down and look to see which of these boxes they want me to use. So confidence, statement of confidence, we don't say this isn't true. 95% of the sentences for the crimes are between blank and blank. That's not what we want to go for. We don't want to talk about confidence intervals like it's a probability. It should say confident in it. It should be a statement about how confident we are. C says that. One can be 95% confident that the mean length of sentencing for the crime is between, and I'm going to 1 decimal place, 50.2 and 59.8. That's all we're doing so far. In a random sample of 49 audited estate tax returns, it was determined that the mean amount of additional tax owed was $3,437 with a standard deviation, oh my God, almost as large as the mean. Holy shit, that's a big window. Construct and interpret a 90% confidence interval for the mean additional amount of tax owed for a state tax return. That's a lot of extra tax. Do people not overpay their taxes? Like I deliberately have extra taken out of my taxes to avoid shit like this. I don't want it. I don't want January, February, March coming around and fucking the government's got their grubby little fingers and hands out going, give me a big ass chunk of your paycheck. I can't afford to have a big old chunk of one of my paychecks come out. This is misleading. We don't need that. We're going to use StatCrunch. We've got stats, T-stats, because we're doing a mean again. One sample with summary. It says 3437 and standard deviation is 2504. And only 49 people were asked. And it wants a confidence interval, but it says 90% this time. So change that to 90%. And they want us to round to the nearest dollar. So we're given a choice of what we want to choose. We want to choose the one that talks about confidence. Of these, A does not talk about confidence, B does not talk about confidence, C does. So I'm going to use C, and I'll use the lower limit that they give me, and I'll round to the nearest dollar, 2837. And if I round to the nearest dollar on the other one, it rounds up to 4037. We've already done half the questions in 9.3. It's been like 10 minutes. If once you get used to using where the stuff is, this gets faster. It gets pretty easy. And thankfully, what we're doing from here on, you're going to be using proportion stats and T-stats even for the hypothesis tests. Because you'll see when we have them opened, like I'm clicking on confidence interval, but the other option is hypothesis test. So you're going to get to it the same way. You're going to enter the same information. Not a lot's changing between chapters 9, 10, and 11. It's going to look very similar. Question number 5, a baseball pitcher's most popular pitch is a four-seam fastball. The accompanying data represents the pitch speed in miles per hour for a random sample of 15 of his four-seam fastball pitches. So we got this data table. I will open it in StatCrunch. And now let's come over here and look at what kind of questions they're asking. Is pitch speed a quantitative or qualitative variable? Sure look quantitative to me, right? There's numbers, there's decimals. It's looking like a quantitative variable to me. It says this is important to know because confidence intervals for a blank are constructed on quantitative data. Which type of confidence intervals are constructed on quantitative data? Anyone remember? Just think about how you calculate a mean and how you calculate proportions. And go, do I need numbers for everybody's response? For proportions, the one with proportions, the thing that we did just a little bit ago, question number 1, it was, do you work from home at least one day a week? And their answer was yes, which is qualitative. Quantitative is used for means because we can add it up, divide by the number. qualitative is used. Let's see. This is important to know because confidence intervals for a mean are constructed on quantitative data, while confidence intervals for a proportion are constructed on qualitative data with two possible outcomes. It's got to have one or the other. Okay. Does that make sense? Like, it's hard to take a mean out of people saying yes, 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 no, 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 yes, no, yes, no, 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 yes. You can't take a mean out of that. So there's no way to get a mean from like qualitative data. So mean has got to go with the quantitative, the numbers. Here it says draw a normal probability plot. That's our QQ plot. QQ. And I'm going to add the correlation statistics and normal quantiles. It says draw a normal probability plot, then determine which pitch speed could come from a population, or whether pitch speed could come from a population that is normally distributed. Now, both A and B look kind of the same. They even go from -2 to 2. This looks like it's going from 85 to 95 miles an hour. And this looks like it's going from 90 to 100 miles an hour. So let's come look at our graph and see which one we had. Ours is going from around 85 to 95. So it's probably A, based on where these dots are lining up. Using the correlation coefficient, did they give us? They gave us a table of critical values. I think it said 15 fastballs. So we're going to need this 0.939. Was it 15? 15 fastballs. So when we're doing these, this is going to be easier with it bigger. When we're doing the correlation coefficient, we're checking it against the critical value for it. Since the absolute value of the correlation coefficient between the z-scores and the observed data, I don't know what that is. We had it here though. It was 0.977. And the critical value was 0.939. It looks like our correlation coefficient is bigger than our critical value. That's what we need. We did this in chapter 4. We even did it on one of the examples last, I don't know, Tuesday, Wednesday, Thursday. One of those days. This needs to be larger, so it exceeds it. And therefore, it is reasonable to conclude that the data comes from a population that is normally distributed. MFers. Now a box plot. I'll say draw boxes horizontally. I don't see any outliers and it looks fairly symmetric, to be honest. It looks like C. A and B are not symmetric. D is symmetric, but it has an outlier. Are the requirements satisfied? So we had to have the correlation coefficient be bigger than the critical value. And we also needed there to be no outliers. And this looks like both are met. An interval can be constructed because the data are approximately normal and there are no outliers. That's what we require. Now it's going to let us do the confidence interval. I'm looking at the sentences real quick. A says 95% confident. B says 95% probability. C just says 95% of the pitchers four-seam fastballs are between. That's not what it is. It's the confident one. That's the one we're going to need. And so we can do we're doing T-stats because it's a mean that we're doing. We're going to do one sample with summary. Not with summary, with data. We have data on this one. One sample with data. So all I got to do is just tell it what column the data's in. We click on confidence interval. It wants 95%. We're good to go. And it says round to 2 decimal places. This is 88.18 for the lower one. And 91.23 for the upper one. Do you believe that a 95% confidence interval for the mean pitch speed of four-seam fastballs for all pitchers in the league would be narrower or wider? Why? And the prompt says the interval for all pitchers in the league would be blank because the variability between pitchers is most likely blank than the variability between pitches for a pitcher. If we include everyone in the league, we're going to have the fastest and the fucking slowest. So I'm thinking the variability is higher for the entire league, which would make the thing wider. Bam. There's a good chance we didn't catch the people on the edges. Sleep apnea is a disorder in which you have one or more pauses in breathing or shallow breaths while you sleep. That's got one of those CPAP machines that makes all the fucking noise. In a cross-sectional study of 430 adults who suffer from sleep apnea, it was found that 258 had gum disease. That's interesting. Note, in the general population, about 17.5% of individuals have gum disease. All right, question A says, what does it mean for this to be a cross-sectional study? So A says the data were obtained at a specific point in time, and the study was an observational study. The data was obtained over the course of time, and the study was an observational study. The data was obtained at a specific point in time, and the study was an experiment. And the data was obtained over the course of time, and the study was an experiment. Now, it doesn't look like they had an experiment. They just restricted their group, their population, to be people with sleep apnea, and just check to see if they have gum disease. That seems like it's not something that's happened over time. It seems like a one-time event, and it was just something you observe. You didn't have to like do a placebo or anything like that. It looks like this was a specific point in time and an observational study. What is the variable of interest in this study? It looks like we're talking about whether or not individuals have gum disease. And whether or not what its relation is to sleep apnea. Because otherwise they wouldn't be asking people with sleep apnea alone. The variable of interest, the thing that's changing is the proportion of them though. The proportion of gum disease present in those with sleep apnea. That's what's changing. Motherfucker. You just want me to go with whether a person with sleep apnea has a gum disease or not? Determine whether the variable in question is qualitative or quantitative. Whether or not they have sleep apnea, gum disease, I don't see any numbers in there, do you? So this looks like a description. It's a qualitative thing. And that therefore is C. The variable is qualitative because it classifies the individuals in the study. Estimate the proportion of individuals who suffer from sleep apnea. All right, this is where we get our trusty StatCrunch open. We're doing proportion stats. It looks like percentage. It doesn't say proportion anywhere, but it is a proportion. And we do not have data. We have generic responses. 258 had gum disease out of 430, which is over half. So we want the one that says confidence. A says confidence, B does not, and C does not. So it's A. There's 95% confidence that the population proportion of individuals who suffer from sleep apnea and who have gum disease says round to 3 decimal places. 0.553, and the next number is a 6, which means I got to round up to a 4. And 0.646, which I do not round. Looks like the 17.5% wasn't needed for this question. This may be a little bit of a red herring right there. I don't know why they call it a red herring. A red herring is like something that's not an important clue, but it's given like it is. Why? Isn't that herring a fish?
I was just gonna say that.
Are herrings not red? They are red. So why is a red herring considered like a wild goose chase? Or why is a wild goose chase called a wild goose chase? Huh? Next question. The Trade magazine routinely checks the drive-through service times of fast food restaurants. A 90% confidence interval that results from examining 535 customers in one fast food chain's drive-through has a lower bound of 175.2 seconds and an upper bound of 178.4 seconds. What does this mean? It means we can be 90% confident that how long it takes to be in the fast food chain's drive-through is between those two times. That's what a confidence interval says. Let's see. A says one can be 90% confident. That's a good sign that the mean drive-through service time in this fast food chain is between 175 and 178. That's looking really good. A is looking good, but I want to look at the rest. B, the mean drive-through service time of this fast food chain is 176.8. They must have had the mean. That is not what this means. C, one can be 90% confident that the mean drive-through service time of this fast food chain, again, is not a number on the interval. We need an interval. And D does not talk about confidence. It says probability. We don't want to say that. We want to say confidence. So it's the one with about the confidence, and it has an interval. That didn't have any work. I like no work. You just have to understand how this stuff works. So confidence intervals have to have a range of numbers. And statements of confidence should say that they're confident. It's not a probability, it's not a chance, it's nothing like that. It's just a confidence interval that about the stuff. For the following, indicate whether a confidence interval for a proportion or mean should be constructed to estimate the variable of interest. Justify your response. Researchers within an organization asked a random sample of 1,016 adults aged 21 years or older. Right now, do you think the state of moral values in this country as a whole is getting better or getting worse? Well, the thing that was asked was choose between getting better or getting worse. So they can answer one of those two answers, which means their response is not a number. This is and there's only two of them. This looks like a proportion thing because we don't have any numbers. So the confidence intervals for a proportion should be constructed because the variable of interest is the number of adults who have a particular opinion, which is a qualitative variable. What the fuck? The confidence interval for a proportion should be constructed because the variable of interest is, it's not the number of them, it's just their opinion. There we go. It's just their opinion. It's not the number of them. That's it for 9.3. We went through all of 9.3 and it took us 45 minutes. That was with me explaining shit. You guys can get through this. Any questions? Yeah.
Were you recording?
Do what?
Were you recording the lesson?
Yeah, I think so.
If I answered, what you asked.
Yeah, I'm recording it. All right, well, let's stop there. I don't want to dive into a whole nother assignment. I don't want to do all your homework for you either. I've done questions from 9.1 and 9.2 in the main class. So. Oh, I have a participant here. Hi, Melinda. We're gonna stop recording there.